After some time, it will be, it will be at this end. Okay, this is having a mass m, length of the string. So let this make an angle theta. The same thing when it is revolving. So here it will have tangential velocity. What is this, sir? We are not understanding. Say very, very simple. These things you can take any whirling object. Okay, no. So I'm suggesting you today after class you just take one thread, small piece of object, anything. Don't tie everyone, and you whirl it, horizontal circular motion, that is. Next again, you whirl it like this. Okay, got this? I think you can do all these things. That's what I'm discussing. This is called a conical pendulum. Why conical? You can see the string what happened will describe the surface of a cone. That's why conical pendulum. Why pendulum? Some bob is suspended. This is not like some 10 kg light bob. That is some small stone, as good as if you're finding difficult. Then what are the forces that are acting? Tension. Then here the weight. Who will balance the weight? So the component of tension. The tension will act here like this. The component of tension will balance, and the other component, what it will do? It will provide required centripetal force. So what are given things in this one? So along y-axis, t cos theta minus mg equal to 0. Then who will provide centripetal force? T sine theta. T sine theta is equal to mv square r. What is T? T is a tension. I'm making clear. T is a tension. Don't try T sine theta minus mv square by r. It's a wrong thing. Who will provide tension? Who will provide centripetal force? Tension provides required centripetal force. This is the basic idea. Now let's do one thing. What is L and R? So sine theta, what you can, some mathematics. Sine theta equal to R by L. We can define this. So let me write. We wanted expression. This instead of V, can you write it any other form? V equal to R omega. So this, shall I put like this? V equal to R omega, M omega square, R it will become. What is R equal to? R equal to L sine theta. So T is equal to M omega square L. So with what angular speed you spin it, that depends on tension. So let me divide, let me substitute this T here. I'm going to substitute the value of, let me write one more equation here. T equal to mg cos theta. This is equation 1. This is 2. Put 1 in 2. So this will become mg cos theta. So what is omega square equal to g by L cos theta. Now what is omega? I should call this as angular frequency. Now how omega and time period are related? We know omega should be equal to time period. I'll write T naught. T is a tension here. T naught is time period. The symbols little bit confusion. So now we know omega. Shall I get the time period? So the expression for time period should be equal to 2 pi by omega. Omega value. So this will be L cos theta by G. This is a time period. What I should call this? Time period of revolution. Now I want frequency. So for frequency, what I should do? F equal to 1 by 2 pi. F equal to 1 by T naught. So frequency is what we define it as. And what F is equal to 1 by T naught. If you want angular frequency is what? The omega. So angular velocity and omega angular frequency are same as it happens here. In this particular case, it is going to be same. I can also call angular velocity as angular frequency. Then this called like a natural frequency. F is. Got the terms now? So this is about the conical pendulum. Why the name? Because of this condition. Will provide centripetal force. Component of tension. Sir, like you said, a force must be there. There's no rule that a force should provide. A component of force or resultant of forces acting towards center will provide required centripetal force. That one. Okay, fine. So this is about the thing that one. So once again, suppose say the object. Now, what are the forces? There is one force acting